Hi everyone. So today let us see logistical regression. So this is another form of regression, and in the linear we saw that we get an output, numerical output, but in the logistic regression, also called sigmoid regression, we use something called sigmoid function. It is a form of activation function, and this is used to calculate when we don't know the output, and the nature of output is in probability terms, and in the whether it is 0 or a 1. So it is generally used in the binary classification problems. So as you can see, this is the formula for the sigmoid function. F of x is equal to 1 upon 1 plus e to the power minus x. This is Euler's value, and what it does is that it transforms the output of a linear regression to value of 0 or 1 within this bracket, 0 or 1. That's what it does. So transforming the linear output using the sigmoid function. This is the linear equation we saw in the linear regression. Z is equal to b plus wx. These are weights and features, and z is the output of linear equation, also called log odds. B is the bias, w is the weight, and x is the feature. And moving on, yes, so here it is shown that left graph is the linear regression, and same graph is transformed into logistic regression with the help of y is equal to 1 upon 1 plus e to the power minus e. Linear equation becomes input to the sigmoid function, because in the uh, neural network, when we use the sigmoid function at the output layer to find the exact probability of a particular outcome. Let's for example that whether an email is a spam or not. So in the hidden layers, before the output layer, there are multiple layers in a neural network. So you there are various activation function used. But in the output layer, this activation function is used. It is one of the activation functions. There are multiple other activation functions. So in this case, the linear equation becomes input to the sigmoid function, which bends the straight line into an S-shaped curve. So this is an H-shaped curve. Notice that the linear equation can output very big or very small value of z, but the output of sigmoid function y is always between 0 and 1. That is the core reason why you use sigmoid function, because in the linear equation the output value can be very large or very small. And also there is a difference in how we calculate logs in the logistic regression also, with compared to how we calculated in the linear regression. So this is a loss and regularization. Regularization. So this is a regularization is a method of to compensate for the overfitting. So that is the so applying regulation is critical to prevent overfitting. Overfitting is what is overfitting is that you the model is has learned too much, or is following too sincerely the training data set. So the core use case or the value of a model, training a model, is that it has to predict on the data which is unseen. But in the case of overfitting, what happens that model predicts the value which it has been trained on. So it only predicts the value, or it uh, tries to uh, predict the value on the unseen data also. It tries to fit that data into the training data that it has seen. So in the linear regression, we use something called squared loss, known as loss function. But in the sigmoid, we use log loss. So we do a take a log value of the loss equation. Log loss equation returns the logarithm of the magnitude of change. Log loss equation, logarithm of the magnitude of the change, rather than just the distance from the data to prediction. So in the linear regression, we saw that there was a straight line, and for the each data point, we calculated that what is the difference between the correct data point and the line plotted. That was the distance we squared. But in this case, we see the magnitude of change and we calculate the log of that change, not the just the distance. So this is a formula. Sigma function xy belongs to D is the data set containing many labeled examples where x, y are pairs. Minus y log y minus 1 minus y log 1 minus y slash. Y is the label in a labeled example. Since this is a logistic regression, every value of y must be either 1 or 0. Y slash or a y mark is a model's prediction somewhere between 0 and 1 given the set of features in it. So regulation is a mechanism for penalizing models complexity during training. And it is extremely important in logistical regression modeling. Test your knowledge. Okay, that's all I have read till now here. And okay, let me take this. Yes. Why is linear regression models output poor predictor of probability? It only has one weight per feature. It only has one output value. The bias parameter skews the output value. Its prediction is not restricted to value between 0 and 1. Yes, that is the answer. Let me see. A sigmoid function never outputs the value 0 or the value 1. It outputs that. It is false. Applying regularization is less important when training a regression model. General no, that is false. Because regularization is applied in the logistic. Okay. Which of the following option matches both linear regression and logistic with appropriate loss function for calculating loss? Linear regression, mean squared, yes. Logistic, no. We cannot call mean. Mean absolute, yes. This one is right. Because in the linear, we calculate mean squared error. In the logistic, we'll calculate log loss. Which of the following is an effective regression technique for logistical regression models? Early stopping. Stop the model in the training only. Let's see the answers. I have scored 4 out of 5. One is correct. Okay, this one is correct. This one is correct. Okay. A sigmoid function never outputs the value 0 or the value. Review the calculating the probability shifts. Okay, I will read more, but I think rest are correct. Yeah. Okay, I will share. That's all. I think I will share more once I read more and maybe do some programming or create some tools to understand a bit better. I'm also reading this for the first time, so a lot to catch up, a lot to understand this conceptually and how it is exactly applied in actual production environment or in actual use case. That's all. Thank you.